Cider.
We're recording, but you can't see the thing.
Oh, that's okay. We'll just pretend. Go.
Look at this one.
No, you look at this.
Go there.
You should go.
Do the uppy downy. Wow. Okay. So, what way is the spring moving as the wave travels down? The spring's moving up and down. Let's stop that one. And instead of going uppy downy, Luke is going to go lefty righty really, really fast. Check this out. So once again, we've managed to make a wave, and what we're noticing is that even though the wave's going like from Luca to me and then back to Luca, the spring is moving like left and right, or up and down. The spring's moving at right angles to the way that the wave's travelling. And so that sort of wave is called a transverse wave, when the medium, the thing the wave's travelling through, like the spring, is displaced at right angles to the way the wave's travelling, like it's going left or right or up and down, the wave's going forward. That's called a transverse wave. Are you ready?
What do I do?
Hang on. What I want you to do is hold that spring really hard against your chest. Watch this. What was that?
Longitudinal.
That was longitudinal. What's longitudinal mean?
When the wave compresses and was it refraction?
Yeah, nice. So, did you notice to make that wave, I moved my hands forwards then backwards. So what I did is had an area of compression that was travelling up the spring towards Luke. How did it feel when it hit you? Okay, maybe if you go, but you can definitely like feel the wave impacting you, and then
I had a cushion.
oh, you had your feather jacket.
Yeah.
How do you get lots of feathers on your shirt? So longitudinal wave is when the medium is moving parallel to the direction of wave travel. So to make that wave, Luke is going to move the spring backwards and forwards, and you should see an area of compression.
Right, forwards and back or backwards and forwards?
Well, probably forwards and backwards. Do you see that area of compression travelling up and down the spring? So that's a longitudinal wave. So two different types of wave. One of them transverse, the medium, which is the spring in this case, is displaced at right angles to the direction of wave travel. The other one, longitudinal, the medium, the spring in this case, is displaced parallel to the direction of wave travel. So in real life, sound waves are longitudinal waves. The little, the air particles are getting compressed and rarefacted as the sound wave travels through the air, whereas light waves are transverse waves. The electromagnetic field is getting wiggled up and down and left and right as the light waves travel through it. So both sorts of waves occur commonly in everyday life. Should we draw some pictures?
Yeah.
Okay, so two different types of waves we're going to run into in everyday life are transverse waves and longitudinal waves. Side view of the medium. Transverse wave, the wave is travelling along and the medium is displaced up or down or left or right. The key thing is that the medium is displaced at right angles to the direction the wave is travelling. And so that could be something like a light wave, could be an earthquake wave, it could be a water wave. That's the sort of waves that we have as transverse waves. The other type is longitudinal waves, and I've kind of drawn particles in the medium. You can imagine those parallel lines as being like rings of our slinky, maybe. And to make an area of compression, one of those rings of the slinky had to move closer to another to make an area of compression, and that's also made an area of rarefaction here. So displacement was that way or that way, and the wave is travelling along, and so the difference between the transverse wave and the longitudinal wave is that here the medium is displaced parallel to the direction of wave velocity. So this sort of waves, things like sound waves, can also be earthquake waves. The P wave, the primary wave, the one that gets to you first, is the one that travels through the molten, the mantle of the earth, and so that's a compression wave, whereas the S wave, the secondary wave, the one that gets to you second, is the one that travels around the crust, and that wiggles the crust up and down. And so earthquake waves can be both longitudinal and transverse waves. And kind of more generally, what is a wave? Both of these things are just energy travelling through a medium. And the cool thing about a wave compared to like a car is that we can use a car can have energy and it can travel, but at the end of it, the car's moved from one place to another. The difference with a wave is that energy can travel through the medium, but once the energy's travelled through, the medium's still left where it was, unchanged. And so a wave is just energy travelling through a medium that leaves the medium in its original position after it's travelled through.